Hello everyone, welcome back to the another session in Design and Analysis of Algorithms, Unit 1, Topic 4, Recursive Algorithms. What is recursion? We already come across with the previous subjects, the recursion meaning. Here in this video, I'm not going to again tell you about what is recursion, but I wanted to teach you about recursive algorithms nature, how it will get executed, how much time it will take, what is the tracing tree of a recursive algorithm, that part we'll be going to discuss. Now, the very common definition what we know is recursion is the function calls itself. Now, we'll see an example. So, this example is what a test code. So, in this test code, I took some n argument. If n greater than 0, printf percentile d n test n minus 1. That means what? Test is a function which is calling itself. Let us assume we'll trace this algorithm. Let us assume n equal to 7. Okay. Now, when n value is 7, we'll come to this block and we'll come to this statement. 7 is greater than 0. Condition true. When condition true, it will get inside of the block. Printf percentile d n. What is n value? 7. So 7 is going to be printed for the first iteration. Now n value will comes out in output and function calls which is test n minus 1. Now this time test of 6. Now again second time. Function is going to be called. Now n value is 6. Condition true will come inside. Now 6 will become in the screen and test of 5. Now the next is what? This time test 5, n value is 5. Test 5 means what? 5 is the n value. Now 5. Now test of 4. Now again test 4 function calls with test 3. And 3 function calls test 2. 2 function calls test 1. Now n value is 1. And still it is greater 0. 1 is greater from 0. Now printf n value is on the screen which is 1. Test 1 minus 1, 0. Now test 0. Now come this. N value becomes 0. 0 greater 0 condition fail. So this time will not go inside of the block. Now check how many times we printed n value. 1, 2, 3, 4, 5, 6, 7. Okay. 7 times n value has printed. That means n times. Okay. Now, how many times function is called? This is what recursive function. This is what recursive algorithm. How many times recursion has taken place? 1, 2, 3, 4, 5, 6, 7. And when test 0 also we were called, no? When test 7 we called with test 7. So count will begin with this test 7, test 6 till test 0. Now count it. 1, 2, 3, 4, 5, 6, 7, 8. 8 times. That means my n value is 7. So n plus 1 times. So recursive algorithm will get executed in n plus 1 times. Now we'll see tracing tree. So the tracing tree is what? Now as far as the example is concerned, so I wanted to give n is equal to 7. Okay. Now tracing tree is what? Test 7. Now when test 7, value 7 will come on the screen because we wrote printf statement. Now test 6. 6 will get printed. Now test 5. Function again will calls with the value of 5. 5 will come on the screen. Now test 4. Now 4 will come. Test 3. Now 3 will come. Test 2. 2 will come, test 1. 1 will come, test 0. This is what tracing tree. Now look at how many times your print statement has executed. 1 time, 2 times, 3 times, 4, 5, 6, 7. So printf statement which takes 1 unit of time, that is called for 7 times. That means n times. N times printf statement executed. Fine. Now, how many times recursion has called? 1, 2, 3, 4, 5, 6, 7, 8. That is what n plus 1. So, recursion calls for n plus 1 times. So, f of n is equal to n plus 1 calls and n times display. Though f of n is equal to order of n. The time to execute this algorithm is what? F of n is equal to order of n. This order of n can be f of n is equal to n plus 1. F of n is equal to order of n. It's not theta, it's order of n. This order of n can be big of n, omega of n, theta of n. Anything you can write in the place of big order of n. So order of n, how we got? N plus 1 is what the recursion calls. N plus 1 is your constant, n will consider. So for this clarity, for this thing, you can see time and space complexities. There we were introduced line count, operation count, and we ignore this constant and we'll take only higher exponential order into consideration. So according to that line count, operation count method in the previous videos, now this is what n power 1 and this 1 is what n power 0. So when you have these two, we'll take higher order, which is n power 1. So the time complexity of recursion algorithm for this is what? Order of n. So this is what your recursive algorithms. Thank you all.